Hello everyone. Welcome to Reverse Engineering Linux 32-bit Applications here at Pentester Academy. In this video, I just wanted to go ahead and introduce this new exciting course. So it's one of our family of reverse engineering courses that we're launching here at Pentester Academy. So I want to tell you a little bit about it. So a high-level introduction to this class. What are we going to cover? All right, so we will talk about preliminaries, getting started. What sort of things do you need to put together? So that's mostly going to be software. So we have software that we need to put together, starting with virtualization software. Now, some of you might say, why would I need virtualization software? Because I'm running Linux. And that's a good question. So what you'll find is that often it can be very convenient for you to have software running in its own virtual machine, software that's under test. It could be malicious, or you just want to isolate it from the rest of your system to see what it's doing. We'll talk about debuggers. So many of you are probably familiar with debuggers that programmers use. So programmers use debuggers where they can find flaws in their programs. Now, what if it's not flaws in a program that I have source code for? Well, some of the standard debuggers are not terribly convenient to use in those sorts of circumstances. So we'll talk about some specialized debuggers that are easier to use when you don't have source code. We will also talk about various scripting tools. As always, we like to have a little bit of automation. So we're going to talk about using things like Python and other scripting tools to make our lives easier. We'll talk about something called decompilers. So a decompiler is a program that allows you to take an executable and turn it back into a C program so that you can study it more easily. We'll also talk about fuzzers. A fuzzer is a program that will send all kinds of crazy inputs into a program. So what would you do with this? Fuzzers are very convenient for locating flaws. I can send crazy inputs into a program and I can cause it to crash. And then if the situation is just right, I might be able to go from merely crashing a program to actually redirecting its execution and doing something a little bit more nefarious. We will get into assembly. We will cover the basics of assembly and calling conventions. We're not going to go super deep because we have an excellent assembly and shell coding course here at Pentester Academy, which I highly recommend all of you check out. Then we're going to get into Stack Overflows. Stack Overflows are some of those flaws that we've been dealing with the longest. It's been a couple of decades that we have been discovering and exploiting Stack Overflows. So we'll talk about the theory of Stack Overflows. How is it that these things are able to exist and be exploited? We'll talk about how you can find these things. Often with a Stack Overflow, you have to calculate some sort of offset. So this offset might contain shellcode, might contain an address that you're redirecting to. So we'll talk a lot about how do we calculate these offsets. We will also talk about how do I deliver my payloads? What are some different exploit techniques? And then we'll talk about measures that people take to thwart these efforts. So people that write compilers and operating systems might do certain things to your programs that will allow these flaws to be somewhat mitigated. So we will talk about those items as well. We'll move on to talking about heap overflows. On the face of it, you might say, well, stack overflows are a problem, so I'm going to allocate all of my memory on the heap, and that couldn't possibly be a problem. Well, it turns out some smart people figured out that yes, even that can cause problems sometimes. So we'll talk about the theory of those kinds of flaws. How do you find them? How do you deliver your payloads, and some effective ways of exploiting these flaws? We'll also talk about format string flaws. So this is somewhat of a newer kind of thing that's been discovered. Many languages, such as C and those based on C, use a format string. And it turns out that many programmers make assumptions of how these format strings might be used, and how things like printf is the most common function that uses a format string. How is someone going to call that? So whenever you make assumptions, that can lead to problems. So we'll talk about format string flaws. How do they exist? How are these things allowed to be out there and exploitable? How do you find them? How do you deliver your payloads, and how do you effectively exploit them? We're also going to talk about something called section overflows and kernel flaws. So you might notice a theme. There's a lot of overflowing here. Maybe an exception to that would be format strings. But can I overflow a section of a program? What can I do with that? Are there problems with a certain operating system kernel? How can I exploit that? So again, we'll get into the theory of that, show you how you can find these flaws, how can you deliver your payloads, and how can you exploit these things effectively. We'll also talk about automation. We all like automation. We like things like Python and other scripting tools. So we can use that in order to initially discover these flaws and also to more easily exploit them. So we'll talk about that a bit. We'll also talk about shell coding a little bit more. We'll cover some of the basics, the theory of shell code. And again, we do have a nice complete course here at Pen Tester Academy, which I would highly recommend everyone go through. So we'll talk about the theory. Where can you get shell code? You decide, well, I don't really feel like I need to write my own shell code. If you do want to write your own shell code, we'll talk about that very briefly. And then finally, we will talk about Metasploit. So there are some researchers out there, they like to do all of their work in Metasploit. So we will show you how you can go from discovering a vulnerability and developing an exploit to creating a Metasploit module for that exploit. Now, something that some of you may already know, if you look at many detecting systems, many intrusion detection systems and intrusion prevention systems, they don't actually detect exploits. They detect people using Metasploit. So we will look into how can I effectively avoid detection, or at least minimize the chances of my being detected should I choose to use Metasploit. So that is a high-level picture of our reverse engineering class, and I'm really looking forward to embarking on this journey with you and I'm glad that you've chosen to join me. So I will see you soon.